Hello, everyone, and welcome to Track 2, Capital Improvement Plan Maximized through Design Build. Throughout the presentation, please use the chat option to post your questions, and be sure to complete the session evaluation to earn CEU credits. And now, it's a pleasure to turn things over to our esteemed panel.
Good afternoon. I'm Brian Bedell with the Haskell Company. We're really excited to be with you. I wish we were in person, but we're excited about this project. Look forward to spending the next hour or so with you discussing some of the great aspects of it. We're going to talk about how Progressive Design Build is able to facilitate a number of capital improvement projects being completed for Macon Water Authority at both of their water reclamation facilities. Joining me today from the Macon Water Authority is Frank Evans. Frank's been the overall project manager, and he's the maintenance supervisor for the utility. Additionally, Ben Adams, who is Vice President and Client Service Manager with Barge Design Solutions, and Mike Hoisington, who is a Senior Project Manager and been the overall single point of accountability for this project. In general, here's the agenda that we're going to talk about today. We'll give a brief overview of the project. We'll be able to talk about how critical collaboration was to be able to make a successful design build team. We're talking about how the delivery method helped to maximize delivering capital improvement projects and overall able to save schedule and dollars to the utility. Talk about an explanation of the services delivered during the overall pre-construction phase and with the real value brought because of Progressive Design Build. And then ultimately looking at some metrics and talking about how we were able to have a successful project and what success looked like to the authority. So with that, I'd like to do a little bit of a project introduction, and I'll turn it over to Frank to talk about the project and the utility. Frank?
Good afternoon. Macon Water Authority origin dates back to 1880. We were created by an act of the Georgia General Assembly to provide public water and sewer services for the citizens of the city of Macon and Bibb County, as well as additional retail and wholesale customers. Macon Water Authority owns and operates one water treatment facility and two wastewater facilities. Macon Water Authority has 1,425 miles of water mains and sewer lines and 51,000 plus metered accounts serving 155,000 customers. In the top photo there, you see an overhead of our Lower Poplar wastewater treatment plant, and the bottom is a overhead of our Rocky Creek wastewater treatment facility. Lower Poplar is permitted at 20 million gallons per day. Our Rocky Creek is permitted at 28 million gallons a day. Both facilities were aging and required significant rehabilitation. Lower Poplar was constructed in 1959 with the last major update dating back to 1984. Rocky Creek was built in 1973 with the last major update dating to 1985. 50% of Rocky Creek's flows come from a local paper mill. Both reclamation facilities were in dire need of updating, as I said. We elected to use Progressive Design Build method for this project. The benefits of using the method were flexibility and collaboration throughout the design, quicker decision-making during concept and construction, owner control of the budget, and quality control. This was the first design build project by MWA. The procurement process based primarily on qualifications with pass or fail elements, project approach, local minority business enterprises, MBE, utilization plan, interviews, and plan to maximize scope with an available budget. Macon Water Authority implemented a team comprised of engineer, operations, and maintenance staff to select processes in need of updating based on the needs of each facility. Both plants needed similar processes updated: influent screening, grit removal, and dewatering. Lower Poplar was also in need of digester improvements, fog receiving station, and an effluent pump replacement. The team visited over 30 plants prior to the project to aid in selection of the equipment. The team spoke with operations and maintenance at these facilities to find out the good and the bad of particular types of equipment. From these site visits, the team selected what manufacturers were best suited for the project. Brian.
Thanks, Frank. As I mentioned at the onset of the presentation today, one of the things that's central to any good design build project is being able to create collaboration within the team. Frank just hinted at one of the biggest ways we did that, and that was finding ways to collaborate from the very beginning by evaluating the overall project and being able to find the optimal solutions to each of the challenges there. It was critical for us to be able to have opportunities for team building so that we could get to know each other as individuals and within the overall team. One of the ways we did that was attending conferences, especially attending WEFTEC, and being able to go and meet with each vendor at WEFTEC for the specific equipment manufacturers we were looking at, be able to weigh options and be able to look at not only initial capital costs, but also operating challenges or operating solutions that they might have. Going to those conferences also provided us good opportunity for socialization, the ability to take in a baseball game or do some other activities, allow the team to be able to start to gel together and get to know each other more on a personal level than just on a professional level. And the establishment of those relationships was really key to the overall success. It was also important that we established early on relationships at each of the key positions. So their overall design build project manager, which was Mike Hoisington, with Macon Water Authority's overall project manager, which was Frank Evans. Our overall field superintendent with the overall plant operators and the key teams out in the field. And then being able to, at an executive level, be able to have a relationship and be able to establish periodic meetings so that those communication channels were open throughout the entirety of the project. Additionally, it's worth noting, we've heard lots of times at this conference when owners advisors have not been an asset to the overall design build team. And I'm here to actually highlight that they were a great asset to the design build team. Jacobs was selected by Macon Water Authority as the overall owner's advisor, and they've been an asset to the project from the onset. They've been able to help to bring validity to both cost estimating, schedule evaluation, and overall decisions made on the project, and have been a great second set of eyes to be able to confirm to the owner and bring the owner to a comfort level that the design build team is doing the things that are in the best interest of the overall authority and of the projects. Great compliment to Jacobs for being a great owner's advisor on the project. Mike?
Thank you, Brian. So collaboration, this is key to a design build project. Early on in the project, we decided to bypass the grid structure completely. The grid system was not working properly, so we were able to determine that the best way and the best use of the funds would be to bypass this structure completely. So early on, this is our superintendent, Frankie McGee. He's out there on the radio coordinating with the plant operations staff. We had to do 5 separate shutdowns of 45 minutes to put in this bypass system. You'll see in some later photos this system in operation. But one of the challenges as we got into this bypass is we saw some unforeseen conditions. The first time we dropped the structure to install this first pipe, we found out that there was roughly 2 yards of concrete that was dumped into this structure that had to be removed before we could do further work. And that concrete prevented the slide gates from closing, the bar screens from functioning properly, and also covered some valve openings, some drain valves. And then there's also other change conditions that we encountered. The air release valves on the influent line that fed this structure were corroded and were not functioning properly. So it caused these two pipes to only allow one to flow at a time, except for in high flow. So that created some additional work, and it also brought attention some other items that needed to be addressed by the Macon Water Authority. Next slide. So maximization of the capital improvements budget. Typical with most plants, the needs far outweigh the budget. So in a way for us to maximize that budget, we wanted to be transparent with Macon on how every dollar was spent. So we provided multiple cost estimates for them to review. We did a conceptual estimate, a 30, 60, GMP, and then one again at the 100% design, just to confirm that if there was any scope creep. And we did this in an open book fashion. We presented a binder that included our estimates and also the proposal backups from each of the vendors. We did a page turn with Macon to show them how each one of their dollars was going to be spent on the project. And if they had questions, we'd narrow it down and we'd go through and discuss how each dollar would be spent. Another benefit of the design build process is we were able to do early procurement of key process equipment. We knew, like Frank had indicated, that there were key structures and components that needed to be upgraded or modified. So we narrowed those down, and we got proposals for each of those components based on making site visits and also engineers' recommendations. And we were able to procure the process equipment early. And that was a benefit because at the time of this procurement, the steel market was very volatile. And so we were able to lock in pricing on that equipment and not worry about cost increases through the design process. It also allowed Barge to design around specific equipment for the project. And the off-ramp option was still there because it was early in the project. But the benefit to the owner was that then in the future, if they did choose to go that off-ramp, they would be able to utilize this equipment as an owner-furnished equipment option and still be able to get the project done.
Thank you, Michael. So from the design perspective, obtaining geotechnical information early on and also reviewing Macon Water Authority's record drawings was important. The findings that we gathered from those sources indicated that we would have to have deep foundations for new structures, and also there was a very shallow groundwater table. So as a result, we decided that if we could utilize the existing structures to the extent possible, we could potentially maximize the owner's dollars. So in terms of both the original contract and the capital improvement additions, that was our strategy, was to utilize existing structures where we could. So an example of this is the grit removal process. As Mike introduced earlier and as shown here, this is a construction progress photo. We reutilized this structure in order to install new pista grit chambers into the sloped rectangular structures. In addition to this, we raised the walls of the channels and rehabilitated the channels themselves. It's interesting to see that although we did have to include a bypass system, that it was less expensive than supporting a flat slab and using freestanding stainless steel pista chambers. There was some very skilled formwork to construct the pista grit chambers, not only being round, but also being on a sloped floor. However, as I said, this was a least cost option compared to other alternatives. I do want to add that we were also able to utilize the existing influent pump station pumps as a part of this bypass, which was yet another cost-saving measure as compared to a standalone bypass system. Another example was the repurposing of existing structures or assets related to the new lime storage component of the lower POPLAR treatment plant. You can see here the existing lime storage silo, which actually appears to be leaning here in this photo. I'm not sure if that's a just a view from the photo or not, but that silo was identified to be abandoned. And also there was an adjacent sludge holding tank that you can see directly behind that silo. Next slide. So as a result, this photo is taken from almost the same perspective. The lime silo structure is no longer there. What we decided to do was demolish the upper portions of the holding tank, and we actually put the liquid lime storage tank and feed components inside of that structure, utilizing the bottom portions for spill containment. We also utilized the lime silo foundation, which was originally where the antenna was attached to the top of the silo. As you can see, if you'll advance the slide, once we abandoned the silo, we needed to reinstate the antenna, and we were able to utilize the existing foundation for the antenna. Next slide. So those are some examples from the original contract, but keeping with the same concept of utilizing existing structures where we could, moving forward into thinking towards the change order work. The Rocky Creek Aeration Basin original contract only included replacement of the aeration basin mixer motors. However, the client knew that there would potentially need to be some cleaning of solids once drained. It turns out that not only did some solids need to be removed, but there were some significant repairs that were needed for the mixer baffle plates, and the bottom slab and side slopes of the aeration basins were compromised. In the photo, you can see where we cut out some inspection ports to evaluate the extent of the compromised side slope slabs and the base slab. With this being a collaborative type project, Macon Water Authority forces were happy to jump in and utilize some of their equipment to help us with the evaluation. And Frank, if you wouldn't mind speaking to some of the equipment and help that y'all provided.
Yes, sir. Macon Water Authority utilized our CCTV to examine the caverns that were found beneath the sloped end. Videos were made and shared with the design team so we could formulate a repair for the issue. The team referred to old drawings and found there were lagoons located in this area prior to the basin being built. This appeared to have led to the failure of the concrete on this end of the structure.
Thank you, Frank. So once our investigation was complete, we memorialized the findings, which included the recommended repairs and a technical memorandum with sketches of repair solutions that were literally sketched on those record drawings that Frank just mentioned. Ultimately, Haskell was able to implement the repairs based on that technical memorandum, instead of the owner needing to compensate the design build team with a detailed design that would be required in a bidding environment. I'll speak to this a little bit more in terms of Haskell being able to construct the repairs on a limited design in a few moments. Next slide. So at the Lower Poplar River Pump Station, at this location in extreme events, the adjacent Ocmulgee River can swell out of its banks and actually flood into the Lower Poplar site in and around the effluent pump station location. So in those rare events, it becomes not only inconvenient, but sometimes maybe even dangerous to get around the plant and operate mechanical or electrical equipment. This was brought up during the construction of these improvements. And during the installation of those pumps, the design build team and Macon Water Authority discussed raising the pump control panels and accessing those panels from an elevated surface. This is a benefit of the flexibility of being able to adapt during a progressive design build arrangement. So ultimately the panels were adjusted up, and we also were able to recognize another very interesting and unique opportunity in that we evaluated a clarifier walkway that was demolished or removed from another location on site, and our structural engineers evaluated the existing components of that walkway and were able to determine that we could use it as a catwalk to be installed to access these panels. The catwalk is currently being modified in order to have the correct braces and mounting components. So they're not shown in this photo right now, but they will be installed adjacent to those panels above the handrail that you can see here. So in this case, we're able to gain efficiencies in multiple different ways. In terms of maximization of capital improvement budgets, what I alluded to earlier is it's not uncommon to see design costs in the range of 12% or so of construction. However, in this project, the nearly $20 million of CIP additions, Barge was able to support the design build team, the Haskell team, with a design cost of approximately only 3.5%. What's neat is in a design build, the engineer is collaboratively teaming so that we aren't worried about providing a quote unquote defensible design. It was also very nice, as Frank spoke to earlier, about the fact that they were able to select specific equipment, and our design was based on those specific make and models of that equipment, in lieu of needing to design to multiple manufacturers as often as it's required from municipal procurement rules in a design bid build project. And lastly, we recognized some economies in scale. For Haskell, this may have meant savings in GCs, but for Barge, in many cases, this meant a single design that was applied to multiple structures or multiple locations. So to recap what I've essentially just described, in design, we were able to base the design on a specific selected equipment. We also didn't need to worry about a contractor looking for change order opportunities, and therefore avoided the need and the cost of a defensive design. Lastly, only limited information was needed as compared to providing every dimension and every call out on each and every detail. It was fortunate for this project, in addition to those aspects, that the nature of the CIP improvements didn't change the treatment processes. So there were no permitting costs or delays either. Mike?
So another benefit of rolling these CIP projects under this base contract was there's no additional mobilizations for Haskell. We already had the crews available. As the base contract work finished, we were able to roll them into the next aspect of the construction. Minimal additional GCs were added. Some of the CIP work did extend the overall project duration, so additional GCs were required, but they were minimal. And then speed of implementation. We didn't have to bid it out, but we did, as we knew what components were going to be required. We were talking to the manufacturers that MACON preferred to utilize. We were able to get pricing, and if we didn't feel it was competitive, we were able to go out to additional vendors and request that pricing. And again, we presented that to MACON in an open book fashion so they could see how all their dollars were being spent. And again, like Ben said, limited design development. We preferred that we'd have like a single sheet with just a couple basic design and a couple comments, notes on there. And if there were changes in the field, the engineers were always available and ready to be adaptive to what we would propose or what solutions were available. And then also, MACON was able to select equipment not on price, but on other factors. So for instance, the river pumps, the low bidding vendor for the river pumps was a brand that MACON was not familiar with, and they wanted to utilize a second priced vendor. And when we did start discussing with the second vendor, we found out that they included other components that were more beneficial to MACON, like a 5-year warranty, which they saw as a value add for the project. Next slide. So also, as we were on site, there was some overlapping scopes of work. So we utilized a lot of MACON's local contractors for the project. And so as we were out there working, our field staff was able to coordinate with those to avoid any conflicts and schedule bust. And we also were able to have a rapid response to issues. While we were working in the aeration basin, we noticed some corrosion problems on the aerator platforms and walkways. As we were down in that area, we were able to do an inspection, notify the engineer and MACON of the situation. And currently they are working on addressing those issues that were found so that we can get this basin back online for MACON to continue treatment. And also safety for the entire project. To date, we've worked roughly 190,000 hours with minimal amount of safety incidents. And we've tried to push that culture throughout the site. Explanation of specific services. So there was a handful of owner requested change orders, and I'll go through that here in a second. So the original contract that we were awarded, the design phase, was roughly 2.1 million. And as we were discussing the design, the belt filter presses at Lower Poplar they were outside the scope. They were a similar concept that could have been utilized with the rotary presses that were being proposed. So MACON had requested a potential design for putting rotary sludge presses in that building. And as you can see in change order 3, they did like the price and also the option of going with that design. Change order 2 was the proposal that we recommended, going with the early procurement of large process equipment. Again, that allowed the design build team to be able to procure the equipment early, lock in the pricing, and give the engineer specific equipment to design around. And it also allowed us to receive submittals and release the equipment for fabrication, because some of this equipment had a year lead time. And so that allowed to be able to hit the ground running once we did get the mobilization. And then the first amendment was the GMP exclusive of the long lead equipment, which brings the total to roughly $37 million. And then as the project progressed and aeration basin 3 at Rocky Creek had never been drained, and with the grit system now functioning, MACON was concerned that they have lost treatment volume because of all the grit that had accumulated in that structure. And so we had coordinated with a plan. It was roughly 2 months of planning, but we were able to drain that basin, grit it. And while we were in there, we actually noticed some other conditions of the structure that needed to be addressed. The baffle plates were fatigued from the years of wear and tear on them. But that was another owner requested change order 6. But the CIP projects that were added to the scope were basic projects that they were going to utilize their own staffs to perform that work. But since we had the field crews available and on site, MACON decided to utilize our team and field crew to perform that work. And then lastly, as part of that initial CIP, they requested us to do some design development for some of the more complex electrical and control base upgrades, and that was rolled into change order 7 that we needed to provide bidding documents to the electrical and INC provider because they were pretty complex of the changes. And then the last change order to date is the repairs to the aeration basin, concrete slab and rope, and also repair the walkways. So that is roughly the breakdown of the project to date. Thanks. So we did carry a contingency for this project, and part of the contract negotiation, there was a request for an owner contingency and a contractor contingency. The owner contingency was for exclusive use of the owner for equipment or upgrades that they wanted to perform when we were in a structure that was something that was unforeseen or missed, versus contractor contingency for items that were missed and not known about during construction. For instance, the concrete that was found in that structure, we utilized contingency to pay for that removal. All contingency had to be approved by MACON for use. And so what Haskell would do is we'd provide a estimate and whatever invoice or quote backup for that, and we'd get approval from them, and also from Jacobs would do a quick review of that and provide a recommendation. And Frank actually was key to this, and he's got a little bit of insight onto that.
Yes, sir. MACON Water Authority, we included contingency dollars for both contractor and owner to utilize throughout the course of the project. This aided in quick decision-making when unforeseen issues or extra necessary work was needed, whereas a change order process would take time and resources, maybe even delays in the project waiting on approvals. Using this contingency dollars, we were able to quickly approve any work that needed to be done. All of the contingency, as Mike said, had to be owner approved before proceeding. And also on a previous slide, you saw where there were change orders. These change orders were initiated by MWA to address issues we had found and capital improvement projects we wanted to do for the next 5 years. Mike?
So I'm going to review both of the plants in terms of what the original contract included, and Mike's going to help me by reviewing slides that follow for the additions from the CIP. So starting with the Lower Poplar facility, the base contract included the items that are shown in green, which will stay green in the subsequent slides that Mike goes over. These included the influent channel screen replacement, new grit removal system, secondary clarifier launder and weir replacement and Stanford baffle addition, the effluent river pump replacement, the liquid lime storage and feed system addition, primary anaerobic digester dome replacement, secondary anaerobic digester dome replacement, potable water storage and feed system addition, an anaerobic digester mix pump room valve repair and replacement, sodium bisulfite storage and feed system addition, fog receiving improvements, then also some structural investigations and other structural improvements.
So for the CIP, the first wave they included work in the existing aeration basin, replacing the tube diffusers, and also the influent and effluent slide gates. And then at the secondary splitter box, they wanted to replace the existing slide gates with new slide gates. Also the effluent clarifier bypass box, and then upgrades to the RAS-WAS building electrical components, and also modifications to the and replacement of the groundwater pumps. Next slide. The second round of CIP projects it included the replacement of the clarifier and thickener equipment mechanisms. These were found to be at the end of their useful life and needed to be replaced.
About 60% of the work actually occurred at the Lower Poplar plant. So about 40%, the remainder occurred at Rocky Creek plant. And those items in the base contract for the Rocky Creek plant included the influent channel screen replacement, the new grit removal system, solids dewatering equipment replacement and building renovations, the aeration basin aerator motor replacements, and then the sodium bisulfite feed system repair and chlorine analyzer replacement.
So for the CIP, again, the aeration basin for 3, degridding the structure, and then also upgrades to the electrical influent pump station VFDs, replacement of the overhead bridge crane at the chlorine building, and then replacement of the motor control center at the sludge feed building. Second round of CIP improvements included replacing the baffles in all 3 aeration basins and degridding basins 1 and 2, automatic controls in the existing sludge press feed building, and also control panel adjustments in the sludge feed building. So measurable metrics of our success for this project. So as part of the project, the local minority business goal was 20%. After the proposals we were able to determine that 17.5 would be what the team could meet. And one of the parameters that Macon required is that the minority business had to be in Macon-Bibb County or in the 7 surrounding counties. So state certified minority businesses were not allowed to be considered unless they were housed locally in one of those 7 counties. So as part of it, we did do several mentoring sessions. We did a safety. We sent the Haskell safety manager to perform a safety mentoring session. We also sent the Haskell estimating team up to show them some conceptual estimating and also how to list exceptions and give a reasonable and qualified estimate for those teams. And also we took on some mentoring for 2 specific local MBEs to try to grow them and develop them so that Macon can utilize them in the future. Another benefit of the project is that we were able to keep 26.5% of the money local there in Macon. I think that's a huge win for Macon, being able to keep that much money local in the area. Thank you.
So overall, when you look at the success of the project, I think it's important to have a few tangible metrics to look back on. And really, both during the original base contract work and then during the subsequent CIP additions, it's obvious to me to see that there was significant design savings using progressive design build on this project, especially during the CIP pieces. Ben showed you some percentages there, and sub 3% design fees on design is really impressive. Great savings and great utilization of the delivery method. Additionally, originally these CIP projects were stretched out over the next number of years, 5 to 7 years, that they were going to be accomplished. We were able to accomplish those really during the course, for the most part, of the original contract and get them up and operational much sooner to the authority. And we were able to have a much higher level of safety and quality around all aspects of construction on each of the projects. So overall, improved safety, improved quality, and then a really high level of integrated operations and maintenance teams and with the overall construction team. When I reflect on the project here at the end of it, it's important to note that lots of times when you get done with the job, no matter how well it's gone, everybody's ready to go back into their corners and do their own thing. And yet on this project, the operations team, the plant staff, the design build team members, we all still like each other. We're still looking to collaborate with one another. We still enjoy being able to socialize and do things. Look forward to the day when we can actually go back to conferences in person and spend time together. But it's been a really successful project at every level, and I really attribute that to the great collaboration it brought through the delivery method and through each of the very collaborative players on the team. And with that, we look forward to entertaining any questions you may have for each of the members of the design build team. Thank you.
We're now entering formal Q&A and chat. Please don't leave this session yet, as you may risk qualifying for CEU credit. Q&A and chat are an official part of your eligibility for CEUs for this session. Remember, you must remain in the session for at least 45 minutes to qualify for CEU credit. Thank you so much to our panel and to all of you for joining us today. And please make sure to complete the session evaluations to collect your CEU credits. And don't forget to go to the Enter Sessions section on the conference homepage to pick your next event. And as always, you can visit the exhibit hall for networking and technical product demonstrations.